Okay, so I'm going to start off with reminding us how to do algebraic equations and inequalities. Okay, Chikoko just asked me to brush up on this a little bit, but she did say you guys should know how to do this. So let's hear what we have to say. Who remembers how we are going to do these ones? All right, let's check. We have A, B, C, D. We're not going to do all of them because this is not the point of our lesson today. But let's start with a nice refresher course of algebraic equations and inequalities. Anyone remember? Nobody feeling confident yet? You can send a message in the chat. Okay, I'm going to start off with the first one. Yes, participate, please. Mathematics is not a spectator sport, so let's participate. Okay, so for the first one, we know we're going to transpose 9x, negative 9x, and the negative 1. There we go, guys. I've given you the first clue. Come on. Anyone want to do this with me? Hi, Anna. Welcome. Welcome. Nobody wants to do this with me. Okay, it's fine. We can all do it together. How's that? So we're going to have a 2x here. When negative 9x gets to the left, it becomes a what? Yes, we are grouping like terms. Change the signs. Thank you, Anna. So from negative 9x, it becomes a positive 9x. Beautiful. Is equal to 6. Again, we have to change the signs. It's going to be 6 plus 1. Now tell me, guys, what's 2x plus 9x? What's 2x plus 9x? 11x. So we're going to have 11x is equal to how much? 7. Now what, guys? I like that we're getting the participation going. I like this. We need more messages, though. There's a lot more learners in this class than the ones that are participating. Please, even if your answer's already in the chat, please. Yes, I see. We divide both sides by 11. Therefore, x is equal to 7 over 11. That was easy enough, wasn't it? That was easy enough. Is there someone who wants to do B with me quickly? Anyone who's going to do B with me? Anybody? No? I'm still on my own. That's fine. Then tell me what to write. We have a 6x. We're grouping like terms, right? Yes. Ha! Volunteers. Hello.
Hi, ma'am.
Hello. Are you going to do this one with me?
Yes, ma'am. Okay, so we're gonna be grouping like terms. So we're gonna move the 3x over the equal sign, which will be negative 3x. Is equal to negative 2 plus 1.
Plus 1. Beautiful.
And then I'm gonna say 3x is equal to negative 1, because you find the difference, keep the sign of the bigger number. And then we're going to be dividing by 3 in both sides. So we're gonna have x is equal to negative 1 over 3, sorry.
Beautiful. Thank you very much for helping me with that one. That was fabulous. Much appreciated, guys. I love when you guys participate. Okay, I hope we have reminded ourselves how to do linear equations. And now we're going on to quadratic equations because we have an x squared. Who remembers how to do these ones? Now we have an x squared, right, guys? So that changes the dynamic a little bit. What is the first step this time? Anyone just tell me the first step in the chat? Anybody who remembers how to do this one? My internet is a little bit unstable, so if you can't hear me, please be like, no, Anna, we can't do that. Look carefully. What do we have there? What type of 2 sets of brackets? Sadula. Let's hear what Sadula has to say. Oh, where did Sadula go?
I'm here. Hi.
Yes. There we go. What were you gonna say?
It's first, it's Mirula, actually, my name.
Oh, Marula.
Yeah,
Oh,
and it's
sorry.
trinomial.
Yes, it is. We're gonna factorize, right?
Yep.
Wonderful. Are you gonna do it with me?
Yeah. X plus 11 and x minus 4.
Okay. Thank you. And now what happens after we factorize?
There's more. Huh.
We have to split them.
Solve.
Remember.
Yes. Yeah, now. Yes. X equals
Great.
negative 11. Oops. Okay.
Equals 0, or x minus 4 equals 0. And yes, Marula has already told us our first solution. Therefore, x is negative 11, or x is
Plus 4.
positive 4. Thank you, Marula. That was fabulous.
Thank you. No problem.
Okay, let me scroll up. I see you guys are asking for screenshots. I'm sorry. There we go. Let's take our screenshots while we do number D. Let's hear. Who wants to do number D with me? Jasmine's hand just went up. Yes, Jasmine. Hi, Jasmine.
Hi. Did I miss anything?
We are
Yes, you
just
did.
revising algebraic equations. And I'm standing in for teacher Coco. Maybe that's why you're confused. You're probably like, what's going on over here?
Oh, hi, teacher
Just
Nelly.
standing in.
Hi, Jasmine. We missed you at the beginning of the lesson because teacher Kate was asking about cringe. Somebody said no cringe. I said, where's Jasmine?
Oh, yeah.
Because we're supposed to explain that. This is
The
class
monitor had technical issues.
Okay. All right, Jasmine. So this is our flash rep. Hi, Jasmine. It's nice to meet you.
Yeah. You too.
All right, let's go, guys. What are my two brackets for D? Now we know that we have to factorize first, right? Before we solve for X. Has anyone found my two factors for D? Two brackets. What will my two brackets for D be? I feel like the D is easier than C, but we'll see. Let's see. What are my two brackets for D, guys? Hi, up here. Welcome. My two brackets for D. Anybody? Nobody has factorized. Come on, guys. Nope. That would be the difference of two squares. Yay! 1 and 4. So we're gonna have x and then x. We're gonna have a 1, a 4. And guys, our first symbol has to be a negative. And what times a negative will give you a positive? Another negative. Okay, so our two factors have to be x minus 1 and x minus 4 because they have to add up to negative 5x. Now we split them. So then x minus 1 will equal 0 or x minus 4 equals 0. Therefore, x is equal to what and what? What are my two solutions for x? My two solutions for x. Asikelelwe, I see you. Beautiful. Asibonge, beautiful. 1 and 4. So x is equal to 1 or x is equal to positive 4. This is supposed to be a revision, but if you have questions, guys, please don't be shy to ask them. Okay. Now let's deal with inequalities. Inequalities are basically the same thing as equations. Now we're just dealing with less than or equal signs or less than or greater than or all of that. Okay, so if this was an equal sign, what would you have done? That's what you must think. If this was an equal sign, what would you have done? How would you have solved this, guys? Welcome, Rebetwe. If we had an equal sign, divide both sides, not yet. If this was an equal sign, what would you have done? Yes, group the like terms. We have to group the like terms. Okay, we follow the same steps. So then we'll have 3x on this side. And when 5x goes over, it becomes what? Yes, we are transposing up here. Thank you very much. So 5x will be negative. Thank you, Anna. This will be negative 5x is less than or equal to negative 8 minus 4, because we are transposing the positive 4 over. Now let's add our like terms. What is 3x minus 5x? 3x minus 5x. Is it just 2x? Thank you, Funzo. Negative 2x is less than or equal to negative 12. Now what? Now what do we do? What do we do now? We want x to be on its own, then what do we have to do now? Divide by negative 2. Negative 2. But now that we're working with inequalities, who remembers what's going to happen to this inequality sign when we divide by negative? What happens to the inequality sign? Because we're dividing by a negative now, so the inequality sign, what happens to it? It changes direction. So it was less than or equal to and becomes greater than or equal to positive 6. So it looks like we remember these. Okay, I think time is of the essence here because I still have to get to today's lesson. So I'm gonna go ahead and go down and say we need to do A. Let's do A. That was beautiful, guys. Really, really well done. Let's do number A. Who remembers how to solve number A? Now dealing with exponential equations. Same rules. We want x to be on its own, right? We have an x over there. And we have another one over there. That's a problem for us. Okay. How do we isolate that x that is in the exponents? Does anyone have an idea? How do we isolate the x that's in the exponent? Anyone have an idea? No? Okay, we can take this out as, someone says expand. Don't we like take 1, 3? I'm not sure what you mean, but we can take it out as a common factor. Do you guys remember? But before we can do that, we have to split these. We have to split these. Okay, now it's getting messy, so let me erase. I love using color, but it gets messy. Yes, that's true. You are correct. We have to split them, okay? So we're gonna first have to split these. We're gonna use the first law of exponent backwards. Okay, so it's gonna be 4 times 3 to the power of 3x times 3 to the power of 2 plus 3 to the power of 3x times 3 cubed. For everyone who's confused about what just happened now, I use the first law of exponent going backwards. Remember the first law of exponent says if you have, let's say you have a squared times a cubed, you can add them. So it's going to be 2 plus 2, right? So they were added, but I want them to be split up. So that's what I did. I went backwards. So I took the 3 plus 2 and I split them and made them have 2 bases so that I can take out 3 to the power of 3x as a common factor. So if I factor out 3 to the power of 3x, what's going to be left in my first term over here? There. You don't have to, Offense. You'll see just now. You'll see just now you don't have to. Okay, guys. What's going to happen when you take out, yes, it's 36. Asibonge has already simplified it. I'm going to rewrite it so people can see where you get it from. It's going to be 4 times 3 squared plus what's going to be left in my second term over here. Recap, why did we say 3 to the power of 3x? Because we want to isolate the x, right? So we took it out as a common factor. You see that? Those two terms both have 3 to the power of 3x. So we took it out so that the x is on its own. Yes. Yes, and then here we'll be left with 3 cubed. Geez, I'm still in my red pen. Eesh. 3 cubed equals 7. Because now, look what happens. Now we can simplify this bracket because it's going to be 9 times 4, which is 36 plus 27 equals 7. What's 36 plus 27? Times whatever that answer is equals 7. I believe it's 63. Okay, so now this looks a little bit better, guys. Do you see where my vision was going? So now we have to get rid of everything that is around the x. What do we do to that 63 to get rid of it, guys? Right now we have 3 to the power of 3x times 63. How do we get rid of that 63? Divide by, not by 3, offense. Remember the 3 is the one with the x. We divide by the other stuff. You're close though, we divide by. How do we get rid of 63, guys? Divide by 63. Divide by 63. We have to divide by 63 because we want these to cancel out. Do you see that, guys? We want those 63s to cancel out so that the x is left on its own. How? Because it doesn't have an x. Yes, we did. We want to divide by 63 to get rid of it so that what's left is the term that has our variable. Okay, so we're doing the inverse of multiplication, which is division. So then you're going to be left with 3 to the power of 3x. Let me divide this so that we don't get confused. Is equal to 1 over 9. So now it looks a bit better, doesn't it? Should look a bit better. Now, we want 9 as something to the base of 3. So how are we going to do that? Who knows how we're going to do that? How do we rewrite 9 as something with a base of 3? Yes, sir. So then 3 to the power of 3x will be equal to 3 to the power of negative 2. Thank you very much, Askonge. Thank you very much. And now we have the same base on two sides. So what happens? What happens if we have the same base on two sides? What can we do now? Yes, Funzo, I see. Now we have our same bases, so we can drop the exponents. Therefore, 3x is equal to negative 2. We divide by 3 on both sides, and then your final answer is negative 2 over 3. Remember how to do this. Okay, I'm going to give you guys a few seconds to take a screenshot. Then we're going to move on to what we have to do today, which is laws of exponents. Okay. Delene, we get it from, we did this 1 over 3 squared. But then you can do the reciprocal and make this 3 to the power of negative 2. Remember the law of exponent that says if you have a negative exponent, negative 4, then you can write that as 1 over a to the 4. So we're busy doing the opposites of laws of exponents, but we're going to revise the laws of exponents just now. Hang on to your hats. I hope everyone has taken a screenshot and is satisfied. I'm not sure why I just drew a random line there, but it is what it is. Okay. Let's remind ourselves of the laws of exponents. Law number 1 says, if you are multiplying numbers with the same base, you're welcome. What happens to the exponents? Now we're doing a crash course on laws of exponents. Multiplying numbers with the same base, what happens to the exponents? Add. You add the exponents. So then for A, what's the answer for A? The answer for A, in exponent form. You don't have to simplify it, okay? I don't want the wrong number. I want it. Oh, Delaney. Sorry. I'm sorry, Delaney. I was wondering that little koliki on the E. I was like, okay, I'm probably not pronouncing it right. Yes, guys, 7 to the power of 6, because if there's nothing there, there's an invisible 1. So it will be 1 plus 4 plus 1, which is 6. Let's talk about B. B will be what? What's my answer for B? We're not focusing on simplifying right now. We're focusing on the laws of exponents. So if you leave it as 7 to the power of 6, then that's fine. My answer with B is going to be m to the power of 8. Ooh, I love it. What's my answer for C? Let's see what's happening by C. Oh, we're not multiplying, remember, we're adding the exponents, Gideon. That little star key is making me nervous because it looks like multiplication. It's okay, don't be sorry, we're here to learn. What's happening with C, guys? Yes, if there's no coefficient here, it's an invisible 1. So then you just multiply the numbers as you would in an ordinary, yeah. So it's going to be 2 times 1, which is 2m to the power of 8. And we already have an answer for number D. We already have an answer for number D. That will be m to the power of 8 and n to the power of 3. Oh, you guys are on fire. You guys are on fire. Why did we get n to the power of
6?
Oh, 6, not 8. So it's, sorry. I'm enjoying writing m to the power of 8. I feel like we've been writing it for B and C, and now I'm like, yeah, let's keep writing it. It's 6, guys. It's not 8. It's 6. 5 plus 1 is 6. The only thing I can say there is we have 2 different bases here, so you need to treat them independently, okay? So for m, you look at the m's, and then you look at the n on its own. That's why n doesn't change, and it stays n to the power of 3. And then for m, you have an invisible 1 over there, as we already said. So it's going to be m to the power of 1 plus 5, which will give you m to the power of 6. Okay, now we're moving on. Oh, E. E is getting interesting. What's happening by E? We already spoke about first law of exponents. Let's talk about the second one. If you are dividing powers of the same base, what happens to the exponents? We spoke about multiplication. If you are dividing, yes, we're going to subtract. We subtract, yeah, but now remember adding is for multiplying, but this time we're going to subtract because we're dividing. So then with E, E can be done in 1 step or 2, it's up to you. What would my answer be for E? What would my answer be for E? Let's say 7 squared. Let's see if it's 7 squared. So you're going to add the ones in the numerator. It's going to be 7 to the power of 8 divided by 7 to the power of 6. And then we minus 8 minus 6. That would be 7 squared. And you guys are correct. Whew, you guys are really killing these laws of exponents, eh? You're really killing them. Okay, what's happening by F? Let's hear what we have to say about F. I know they're doing so well. Like, I'm just like, what's happening by X? F, of course I'm gonna say X. What's happening by F? Anyone have an idea what's up with F? No? Okay, let's check. Numbers. Can 3 go into 8? The numbers are not going to change, okay? Now let's think about the laws of exponents. What is the condition for laws of exponents? The bases have to be what? The bases have to be what? In order for you to apply the laws of exponents, the bases have to be the same. Are my bases the same in F? Are my bases the same in F? No. So can we simplify this expression? Think about it carefully. Can we simplify it realistically? If my bases are not the same, then there's nothing we can do about it. So your answer is literally the same as your question. Okay, be careful of this, guys. A lot of teachers will put it in a test because we're very eager to apply the laws of exponents, and we forget that one condition, which is the bases have to be the same. Okay, so if the bases are not the same, you cannot simplify it. You just rewrite it the way it is. Okay, that was a trick question. That was a trick question. Okay, let's go back up. Let's go back up. G. Let's work with G. What's happening by G? Oh, screenshots. Anyone wants to take screenshots? Let's deal with screenshots quickly. There we go. A few seconds for us to take screenshots. 4 plus 6 is 10. Okay, we're already halfway with answering the next one. So in our numerator, we're going to have p to the power of 10 divided by p to the power of 3. So what is my final answer? Yay! You guys are really doing well. So it's going to be p to the power of 10 over p cubed. And this will give me p to the power of 7. Now let's see with h. H is the same thing. They start looking a little bit more complicated, but that's only because they're two different bases. So you deal with the sevens on their own. So we have sevens, sevens, sevens. Yes, Jasmine. Jasmine. Hello.
Oh, hi. Where does the P7 come from?
Remember, when you're dividing, what do you do to the exponents?
Oh.
You subtract. So it's 10 minus the 3 in the denominator.
Sorry, I got lost for like a second.
It's okay. It's okay. There we go. So now Jasmine is with us and we can move forward. Now let's deal with H. Let's deal with the sevens first. What is the exponent for 7 in the numerator? Let's first simplify the numerator. The numerator will be, yes, Asikelele has told us it will be 7 to the power of 4. And then what's the exponent for 7 in the denominator? Yes, so it'll be 7 to the power of 2. And Aswange, I think, wants to say it will be 3 to the power of 3. Beautiful. But now we can still simplify. We still have the same base of 7 in the numerator and denominator. So this is a two-step one, right? So you see there, we still have 7 there and another 7 there. So now what's my final answer? What will my final answer be? Yes, Jasmine.
7 to the power of 2 and the 3 to the power of 3.
Divided by 3 to the power of 3. Yes, Jasmine. Thank you very much. We are with me today. Okay, let's go to I, guys. Let's talk about I. This time we have an extra law of exponents. We have an extra law of exponents. One times the, oh, it has to be in the denominator. Okay, I hope you saw that. So the 3 cubed has to stay in the denominator. You cannot take it up, otherwise it's going to have a negative exponent. Okay, additional, excuse me, we have an additional law of exponent here. What happens when you have two bases, let's say either a, b, or squared? What do you do with that exponent? What does it mean? Which the law of exponents say what? What must happen with that 2? Yes, Jasmine?
The a and b have to individually be multiplied out by the 2.
Yes, so you distribute that exponent, right? So then it will be a squared and b squared, right? I think that's what Jasmine was saying. So then we're going to apply that same law over here. This 2 that's in the denominator has to be distributed into the bracket. Okay, so I'm going to deal with that first. I'm going to rewrite my numerator as is. I'm not going to mess with it. And then I'm going to go down and simplify my denominator. So I have 5d times 5e squared all over ed times. Now we distribute 5 squared e squared d squared. Beautiful. Now let's simplify the numerator. Is there anything we can simplify in the numerator? Look carefully. Is there anything we can simplify in the numerator? Check again. Thank you. 5 times 5. Do you see we have a 5 times 5 there? So then this 5 times 5 will then be 25 d e squared. And then we go to the bottom denominator. In our denominator, is there anything we can simplify there? Okay, we have a 5 squared, and that's going to give us how much? $25. So we also have a 25 in the denominator. How many d's are in the denominator? Thank you, Asponge. E cubed and e cubed. Now we can simplify even further, right? So let me do this. Let's open up some space. We can simplify even further. What's 25 divided by 25? What happens to those 25s? What happens to the 25s? There we go. They cancel each other out, or they divide into each other, right? So 25 is gone. And then it's going to be d to the power of what? And e to the power of what? Let's hear. D to the power of? Is it 2? Remember, it's always the numerator minus the denominator. So it's going to be the one at the top, which is 1, minus the one at the bottom, which is 3. Same with e, 2 minus 3. So that's going to give us what? There it goes, negative. E is going to be -1 and D is going to be -2. But we don't like negative exponents, guys. We don't like negative exponents. So what does the law of reciprocal say? How can we make these exponents positive? How can we make the exponents positive? Think of the law of reciprocal. It says a to the power of -2 is the same as 1 over a squared. We just used it just now up there with the 1 over 9. Do you remember? So how am I going to make these exponents positive? Anyone? So this will be the same as 1 over d squared e. Do you remember, guys? It was so quiet for a while. Thanks, Asbonge, for trying. Whew. I was just like, is anyone there? I thought I was disconnected for a while. So the law of reciprocals, guys. So you're going to put it over 1. And then that will make our exponents positive. Asikelelwe, do you remember the law of exponents? The law of reciprocals. So remember, if you have 2 to the power of -4, this is the same as 2 to the power of -4 over 1. Now, if you want this exponent to be positive, you're going to swap them around. If it was in the numerator, you're going to put it in the denominator, and it's going to be positive. Okay. So that's what we did. It works the other way around. If you have 1 over, let's say 2 to the power of negative 3, and you want that to be positive, you can take this up and make it the numerator, and it will be a positive exponent. Do you remember that law? I hope I reminded us of the law. But isn't 2 to the power of 4, of negative 4 over 2? No, no, no. So you're saying, isn't this equal to negative 4 over 2? No. Remember, this negative 4 is in the exponent, okay? So you cannot make it the numerator. You have to move the whole power. The whole power has to move to the denominator, and then you can make it positive, okay? We should all revise our laws of exponents. Is it correct if we say 1 over 8? Yes, that is fine. That is fine. Okay, but we need to understand this law, because if we're using variables like this question, then you won't be able to simplify it and make it 1 over 8 or a numerical number, like a numerical answer. So you have to know these laws, guys. We have to go revise our laws of exponents. Okay. Wonderful. Now let's continue. I think we can do one more of this, and then we're moving on to the next part of today's lesson. Let's do one more of these. Oh, if it doesn't make sense, actually, let me show you something. If it doesn't make sense, remember we had 1D in the numerator, right? And we had 3 in the denominator, times D, times D, times D, right? Now, this first one will cancel with the one in the numerator. And then there are 2 left, but they are left in the denominator. So you cannot say D squared. It has to be 1 over D squared. Same with the E's. We had E times E in the numerator and 3 of them in the denominator. So 2 of these will cancel, but 1 is still left at the bottom. Do you see that? Oh, there's a hand. Let's hear. Question. Apiwe?
Hi, ma'am.
Hello.
Ma'am, I actually wanted to try out J.
Oh, okay. Wonderful. Someone wants to speak to me today. This is great. Let me hurry up before you change your mind. Okay, let's do J.
So ma'am, I actually said 2 raised by 4 because I simplified 16. And then I said
Okay.
C raised by 4, F raised by 3.
All right.
Divided by 2 raised by 5.
Mhm.
C raised by 3. And then F.
All right.
Then I said 2 raised by 4 minus 5. C raised by 4 minus 3. Then F raised by 3 minus 1.
Mm-hmm.
Then I got 2 raised by negative 1.
Mm-hmm.
C raised by 1. And F raised by 2.
Okay.
Then I said 1 over 2 raised by 1.
Beautiful. Mm-hmm.
C and then F raised by 2.
So then that one is going to multiply with C and F raised by 2. So what's my final answer?
Oh, no, ma'am. I was like 1 over 2 raised by 1 CF squared.
Yes. So that one that you left over is going to just multiply with CF squared. So your final answer is just CF squared over 2. That was beautiful, up here. I love it.
Thank you, ma'am. Yo, I was so nervous. Yo.
And you're superstar. Why are you guys nervous? Come on.
Yeah, that
Guys,
was
yeah, let's
beautifully
give
done.
a round of applause. That was beautiful. That was beautiful. See, guys, Apiwa is proof that if you know your laws, you can do any of these questions. Now we have to move to the next part of today's lesson. Don't hate me. Don't hate me, okay? Don't hate me. We're stepping it up. Stepping it up. Jasmine, hands is up. Yes, Jasmine.
I got a question, but like it's not about algebra. It's regarding a graph, a tan graph.
Okay, can you wait until the end of the lesson? I'll stay over with you, okay?
Okay,
All right.
no problem.
Okay. Okay. So guys, now we're stepping it up. Né? Apiwa has concluded the previous section so beautifully that it's time to step it up. But guys, these look like the ones we did above there, right? Do you remember when we started off? We said we want to isolate this 3 to the power of x. You cannot cancel it with the one in the denominator because we have a negative there. We have 2 terms. Okay, so we want to factor out this 3 to the power of x. Okay, so remember what we said? We said any exponents that are added, we split them up. So you say 3 to the power of x times 3 to the power of 1 minus 2 times 3 to the power of x, all over 3 to the power of x times 2. Okay, who remembers what I did after this? Who remembers what we do after this? What happens once you split it up? What was the point of splitting it up? So that we can do what? Anyone remember? If we have our notes there, we can check in our notes before writing any. Yes, we take out the common factor, which is 3 to the power of x. Okay, we're not going to have enough space for this. So let me think of a vision and mission. Okay, I'm just going to write them at the bottom, which is going to be 3 to the power of x. So in our first term, what's going to be left here? When I take out 3 to the power of x, what's going to be left over? What's left when you take out 3 to the power of x in our first term? Anybody? Just 3. Thank you, Samuel. It's 3, guys. Look carefully. It's 3 to the power of x times 3. So if the 3 to the power of x is out, then the 3 is still there, okay? Minus, thank you, Aspongi. Before I even asked what's left over in the second term, it's a 2. Okay, divided by 3 to the power of x times 2. And now we can divide them. What's 3 to the power of x divided by 3 to the power of x? What's going to happen to those? What's going to happen to them, guys? 3 to the power of x over 3 to the power of x. Yes, they're going to cancel each other out. Okay, equals. And then 3 minus 2. What's 3 minus 2? Yes, we're getting this, guys. So what's going to be left in the numerator is a 1 over the 2 that was left in the denominator. Yes, now let's do b together. Now that I've reminded us how to do this, let's do b together. What is my common factor in b? Let's check. What's my common factor in b? We said we're taking out a common factor, right? So let's look at b in the numerator for b. Okay, let me be specific. In the numerator for b, what will be my common factor? Leona says just 2. Is it just 2? What can I take out? Actually, the first step is to split them up. Yes, as long as it's 2 to the power of 2x. But let's split them up. We don't like it when they have these pluses, right? So we rewrite it as 2 to the power of 2x times 2 to the power of 3 minus 5 times 2 to the power of 2x times 2 to the power of 1. Okay? 4x plus 2. Yes, so we have established what my common factor is. I'm going to do this because we're going to need a lot of space for this one. Right. So you guys are saying to me, 2 to the power of 2x is my common factor. What is left over in my first term? In the numerator, we are taking out 2 to the power of x here. So what's left? What's left over? Nope, not the minus 5. I've included the minus 5. It's not supposed to be there. Sorry. Sorry. Undo, undo, undo. My first term ends there. Whew. What's left in the first term, guys? If I take out this 2 to the power of 2x over here, what am I left with? Eight. Thank you. 2 to the power of 3, or if you're going to simplify it, you can just write it as a 8 minus what's left in my second term. What's left over here? As long as it's the 10, it's 5 times 2, which is indeed a 10 over. Now we have a problem. We can't exactly cancel anything in the denominator. Let me split that. 4 to the power of x, 4 squared. What's going to happen now, guys? What can we do in order to cancel out those x's? How did we get 8? Liabona, what was left over was 2 cubed, which is the same as 2 times 2 times 2, which will give us 8. Okay. Okay, guys. Now what's happening there? That 4 to the power of x is a problem for us. How can we simplify that in order for it to cancel out with the 2 to the power of 2x? Does anyone have an idea? Anyone? Yes, offense. You make it 2 squared. So we're gonna change our 4 to a 2 squared. Oh, you guys are just brilliant, man. I love being this close. Okay. So in the numerator, we have a 2 to the power of 2x. If I simplify my bracket, I'll have a negative 2 over this 4 can be 2 squared times 60. And if you have that, then you can make these 2 to the power of 2x over 2 to the power of 2x times 16. Beautiful. And then what's going to happen to the 2 to the power of 2x's? What's going to happen to the 2 to the power of 2x? What happens with them? Whoop. They cancel out. Whoop, whoop. And you're left with negative 2 over 16, which we can simplify to what? Which we can simplify to what? Negative 1 over 8. Ooh, beautiful. I think I'm going to end our lesson there. I think that was a lot of brain work. Whew, that was a lot of brain work.